Okay, welcome back, ladies and gentlemen, for an extra little video on solving equations. This is basically going over some problems off Pre-Calc Worksheet Part 2, and here is an example of a simple one. Say you wanted to do number 2, and it's secant squared theta minus 4 is equal to 0. All right, first of all, you need to get these down so that they are just one function, and this one is just one function. It's secant. And if I take secant squared minus 4, I add 4 to both sides, I'll have secant squared theta is equal to 4. Now, if I want to get that secant squared off of there so that it's just plain secant, I can do that by doing a square root. I also could try to get that secant down to another sign that we know even a little bit better, another one of our trig functions, and that would probably be get secant changed to 1 over, I hope you know this one, secant is 1 over cosine. So that's 1 over cosine, and that's squared equals 4. If I take the square root of both sides, the square root here and square root here, I end up with 1 over cosine of theta equaling square root of 4, which is 2. And since I did a square root of both sides, I got to remember it's plus or minus 2. All right, next thought. If I want to get that cosine to be completely alone, I'm going to have to get rid of that 1 over cosine. All right, so I could do that. I could have done that earlier in the problem, but this is going to work. So I'm going to get 1 over cosine of theta equal to 2. And I'm doing the other side, 1 over cosine of theta equal to negative 2. All right, still trying to get that cosine alone. I'm going to multiply both sides by cosine, and I'll have 1 equals 2 cosine theta. And still trying to get that cosine alone, I'm going to divide by 2 on both sides, and I'll have cosine theta is equal to 1/2 on this side. And over here, same thing, I'm going to multiply both sides by cosine. I'll have 1 equals negative 2 cosine of theta. Then I'm going to divide by divide by negative 2 on both sides. Divide by negative 2. And this cancels, and I have cosine of theta equals negative 1/2. So basically, I got two answers here. I got one set of answers that has to do with this one, and one set of answers that has to do with this one. So the way I'd think this through is cosine of theta equals 1/2. Well, I need to figure out a triangle that would work for this situation. Yes, I could do it off of the unit circle. If you're good at that, go ahead and do that. But all students take calc reminds me that cosine is positive. See, this is a positive number in this one and this one. And so cosine is positive in this quadrant right here. So I'm going to say, if I make a triangle like this with a theta right there, cosine is adjacent over hypotenuse. And then I can figure out that this one's the square root of 3. Oh, that's one that I know. I know that one. This is a 30, 60, 90 triangle. And the angle that I'm looking at here for theta is across from this side, so that's not the 30 degree, it's the 60 degree angle. All right, so basically I figured out that 60 degrees is one of my answers here. But don't forget that you have two answers for most of these kinds of problems. And in this case, we'll have two answers for this one, and then two answers for that one. All right, so if it's 60 is one of its answers, then I got to go to the other side and say, all right, there's another place where cosine is positive, and that's down here. So I have to make another triangle like this, where this is also 60, but we don't say 60, we go all the way around here and say instead that that's positive 300. All right, that's how you do that side. Now over to the other side. I got to find the angles where cosine is equal to negative 1/2. All right, if I make my little all students take calc thing, it'll tell me where cosine is negative. Cosine is negative here and here. So if I go over here and make the triangle, it's still got to be 60 degrees. But I wouldn't say 60, I'd say this angle right here, which is going to be 180 minus the 60, which would be 120. And then it has to be over here is the last one, and that's 60. So that's 180 plus 60. which would be 240. So we've got 60, 120, 240, and 300 for that one. Next one I want to do with you is a really tricky, evil one, number 6. If you look at number 6, again, your goal on these is to try to get it down to one function. And this already is down to one function. It's cosine of 3 theta minus root 3 over 2 is equal to 0. All right, so it only has one function. So that's the easy part of this one. So I just have to add plus root 3 over 2 to both sides. And then I end up with cosine of 3 theta is equal to root 3 over 2. And from here, if I just say what angle right here would work and give me root 3 over 2 for an answer. Act like this is a separate letter, like M or something. A lot of times in calculus you do U substitutions, you use the letter U. So if I wanted to, I could just think of this as one letter U. That thing right there needs to be, and we can go off to the side and figure out exactly where it is. All students take count. This is a cosine being positive, so it's here, or cosine is also positive here, and so it's like this, and then this angle U, or whatever that angle is, has got to be, let's see, opposite. So cosine is adjacent over hypotenuse, so the adjacent side here would be root 3, and the hypotenuse would be 2, and that would mean that this side here would have to be 1, and then I know that I'm dealing with a 30-degree angle. All right, so what I just figured out is that this whole thing here needs to be 30. So what am I saying? I'm saying 3 theta has to equal 30 degrees. Now don't forget, it's in 2 quadrants, so I need to go over here now and do the same exact thing, because remember it worked here and here. So if this right here is 30 degrees total, then the angle we're talking about is 330 degrees. So 3 theta, this thing we're calling U for right now, is also equal to 330 degrees. So you might be wondering, if you looked at the answer for this, why is there so many answers? Because it seems like if 3 theta equals 30, then theta equals 10 degrees. Good. And then if 3 theta equals 330, I divide by 3 on both sides, and I get theta equals 110 degrees. All right, so theta equals 10 and theta equals 110. So some of you are like, so where is the rest of those angles coming from? Well, remember that if we wanted to, we can add 360 to this angle and get another place that works. So 30 plus 360 would also be a place that works. But wait, you say, we only want answers that are less than 360. But remember that we're going to divide this by 3 in a second. So if I add 360 degrees to that, it'll say 3 theta is equal to 390 degrees. Then when I divide by 3, my answer is going to come out less than the limit. You know, it's supposed to be 360 or less, and it will be. So when I take and divide by 3 on both sides, theta then is 390 divided by 3, which would be 130 degrees. You see how we get extra answers here? So these two were easy to understand. Here's one more that works. Then if I add 360 more to it and say 3 theta is also 360 plus 390 makes 770, and divide that by 3, theta could be something else. And again, this is an answer that's less than 360, so it's going to be okay. So if I take 770 divided by 3, wait a minute, I just caught something. This, if I add these two together, I actually get 750, not 770. Okay, because that's making more sense. If I take 750 divided by 3, that'd be 250. All right, so there's another possible answer. And you just keep on adding 360 to both this little equation and this little equation. I can add 360 to that also. And you're going to keep on dividing by 3, so you're going to keep on getting answers that are less than 360. So here's 2, 3, 4 of them, and you can do the other 2, I bet, by yourself. All right, here's another one I want to show you. Let's see. Let's do number 8. I had a bunch of kids in my third hour class really struggling to figure this one out, and I said I would record this one for you, so here you go. Number 8, tangent of theta minus 6 cotangent of theta plus 1 equals 0. I don't know why my computer's going so slow right now, but it's kind of messing up my writing. Cotangent. There we go. Okay. On this one, remember that theme I'm trying to develop here is that you want to get these boiled down to just one function, like tangent the whole way through. Can you see that if we change this to 1 over tangent, then we'll have tangent the whole way through? Tangent theta minus 6, and I replace this with 1 over tangent of theta plus 1 equals 0. Again, I know the answer is not just jumping right out at you, but this has tangent only as the only function in it. So that means there's a chance I can solve it. Okay, so now I have to try to get this tangent out of the denominator. If I ever have a situation where I want to get rid of a fraction, like I'm going to go off to the side here and say, let's say I had 3x squared plus 1/2 x plus 7. Do you get how I could multiply by 2 throughout the whole equation? Because then it would get rid of that fraction, and I'd end up with 6x squared plus, if I take 1/2 times 2, that would be 1x plus, multiply everything by 2, so 7 times 2 is 14. This would be the equivalent expression to it. So basically, I just multiplied this whole equation through by 2 to fix my fraction problem. Same idea, if I want to get this one fixed, I can get rid of that tangent in the denominator there by multiplying everything by tangent. So then if I multiply this by tangent, and this by tangent, and this by tangent, and this by tangent, here's what I get. Tangent squared of theta minus, if I multiply by tangent, the tangents will cancel, so it'll just be minus 6 plus, and then 1 times tangent is tangent of theta, and then 0 times tangent is 0. Let me just make sure for a second I did that right. Multiplied everything by tangent. Yep, okay. Now I'm going to rearrange it, and I bet you're going to recognize it. Tangent squared of theta plus tangent of theta minus 6 equals 0. Do you recognize that that is a quadratic? If I replace my tangent with an x, it'd be like x squared plus x minus 6 equals 0. And I encourage you, anytime you've got something that smells like a quadratic, because you've got a squared here and a not squared here and a constant right there, then you can just replace whatever function it is, sine or cosine or tangent or whatever it is, with just an x. And then go ahead and factor it from there, and you'll have, for instance, x and x, and then instead of the minus 6, I put plus and a minus, and I got to go, how do I multiply and make a 6 with something that will also add up to positive 1, and that would be positive 3 and negative 2, right? Okay, and then my final answer comes out to x equals negative 3 and x equals positive 2. And it'd be so easy to forget right here that you earlier had taken out the tangent and put in the x. So now you have to go put in the tangent again. Wherever we have the x, we now have to substitute the tangent back in. Tangent, not squared, just tangent of theta has to equal negative 3. And over here, tangent of theta has to equal 2. All right, so I substituted tangent back in for my, instead of my x, I have tangent again. So now I'm going to get two sets of answers again. Okay, so now what I've got to do is get the tangent solved over here, and I'm going to use my calculator. Inverse tangent of -3 will tell me what the calculator thinks the answer is. And the calculator thinks the answer is -72 degrees. I'm rounding a little bit. Okay, if that's -72 degrees, why isn't that okay? Because our direction said we wanted answers between 0, or sorry, this is theta, between 0 and 360. So we want an answer between 0 and 360, and that's not between 0 and 360. So we have to go over, look at where that really is. All students take calc at -72 is down here. That would be like this is -72 right here, this angle. So what is that in terms of a positive degree? Well, we go all the way around the horn here, and we could take 360 and take away the 72, and we end up with 288 degrees. This one will be 288. So that's 288 degrees. Where else is tangent negative? This was one of the spots I could draw the triangle where tangent was negative. Here's another spot where tangent is negative. And if it's supposed to be -72, according to the calculator, then I'm going to clean off. Actually, I'm just going to make a new one here. And I'm going to say all students take calc. And I'm going to do it in this quadrant now. And this is supposed to be 72. Then this would be 180 minus the 72. 180 minus 72 is 108 degrees. Remember, for each part of this, there's going to be like 2 answers for this, and there's going to be 2 answers for that. Okay, so now a whole different question. What angle does tangent of what angle is 2? So I can go into my calculator, do inverse tangent, inverse tangent of 2, and it tells me it's 63.43. I'm going to round that to about 63 degrees. And is 63 an okay angle? Is it within my little zone? Yes, it is. So I can have 63 degrees be one of my answers. And then where's the other place where tangent is positive? Besides in the first quadrant, all students take calc. This one was the spot I just did. The other spot where tangent is positive is down here, and so this would be okay, and so this would be a 63-degree angle. So I take 180 plus the 63, makes a total of 243. 243 degrees. All right, so final answer, 4 answers. There's this side of the equation and then that side of the equation, and they both end up having possible answers. So again, I want to double check, make sure I did that right. Answer key says 288 and 108 and 63 and 243. Yeah, got it. Okay, these are tough, no doubt about it. And Mrs. Richens said not to have to record too much of this because she is going to put up a key on Blackboard where it has all the work shown out on how you can get them to come out to these answers. So she's going to post that in the next day or so, so you can look for that for extra help. All right, have a great day.